All right, so the example I like to give is, let's say you have some data, some x and some y. Let's, come on, get out of here. Okay. Let's get my faculty office hour. Okay. So let's say you have some data where data.frame is, sorry, can I make it brighter? No. Anyway, so like df is data.frame, x is our norm 100, like let's say 1,000, y is our norm 1,000, and like group is, let's say sample letters, size equals 1,000, replace equals true. Okay? So, I didn't say, so we can even say strings as factors. False. By the way, Sean, have you ever seen the strict package? There's a package, for example.
Oh, it like makes all these warnings happen.
Warnings are stopping, so like, it says like, if you try to do data frame without specifying strings as factors, like, you can't do it. If you say like df bracket like 5, well, I have to say df bracket 5. It says like, hey, you have to specify drop. I'm just subsetting a single column, like that kind of stuff. Anyway, I'm going to restart my R session so we don't have to do that. But strict, if you don't like some of the, if you want things to be more rigorous, it can let you do that. All right. So many times what I want to do is just like G, and I always use the Ggplot function. I don't tend to use Qplot for quick plot. Yeah, just I don't know. I like to do the mappings myself. Right? So just make the base layer, the canvas. Right? Oh, sorry, I don't want to use group. I want to color it by group. So many times I want to do just data. So many times this is what I want to do. All right? I want to just do a scatter plot and group it by letter. So I'm going to just do letters 1 to 5 because, you know, having like 100 different groups isn't always that great. Let's zoom into it. So like, all right, like let's say I want to do that and I want to do a smoother. All right? That, at least for me, and almost always I say SE equals false for the standard error. Almost every time, like I want to do that, like with my data. When I have multiple groups, 2 continuous variables, like that's my go-to for like, you know, a Ggplot. Also, I like it where I might do a facet where like, yeah, I'll show you the code in a second. So maybe I want to separate them by facet. Maybe I still want the colors in there. But I want a smoother separately for each plot, right? So, okay, so what I did was, let's just call this G again. So, right, so first we specify the data set, the mappings, and in this case the X and the Y variables, and I want to map the group variable to color. I want to add points to it. I want to add a smoother, right? And because and order matters here, right? So like, if I didn't specify the color first, I could. Sorry, the order matters in the sense it's like when I define G, it already knows that everything I want to do after it wants to have color to be mapped to the group variable, right? I can override that if I want within each geom. So what I'm saying is I could say, hey, don't do anything, don't define globally the color to be, or group to be mapped to color. I can say only for the points, right? Make color the group, but this does something very different. So what it does is it groups the data, or it colors the data by the grouping variable. But when I set that aesthetic within the geom underscore point, it says, you know, plot the colors differently, but that's not set globally. So now if I say smooth, it gives me one smoother for all the data, right? And when I say facet underscore wrap, this is a formula syntax, right? So this is different, right? This is now not doing things globally, right? So facets and mapping things to a variable have slightly different behavior, right? So when I say facet wrap, it says break things out. It's more or less like subset the data and then do whatever you're going to do, whatever operations on that data set, and then plot it in each panel. So each one of these is a smoother for that specific subset, but they're not now colored, right? They're not colored anymore, right? So sometimes we want something like this. Sometimes we wanted something like we did before. So we could still say in here, if we said AES color group, right? Now it's going to be colored by group again. Note though, if we zoom in, I don't know if I can zoom in anymore, but there is a faint outline on these lines. That's because here, when I redefine G has a smoother on there.
Oh, okay.
Right? So what we really want to do is like G2, right? We redefine that, and then I can say like G2, because it actually plots two separate smoothers on there. And that's fine for, I mean, you don't really see the outline, but it's important because a lot of times when you actually have to do the low S smoother, right, you don't want that to happen. You don't want that to, oh, sorry, that's wrong. So G. You don't want to have to compute that multiple times, right? Because if you have a lot of data, that's not so great. So if we zoom in, and if you look at the video, you should be able to see that there's no faint lines on here, right? Versus what we did before. So that really, for me, the way I would think to do it in base is like, first off, like you have to get your axes set the same, right? So you have to get max and min. You have to do a for loop by group usually, and you have to compute the low S on your own, or you do scatter.smooth with par mf row. But you have to set x and y limbs, and that really is where I think Ggplot really can shine. And I really like Facet Wrap because then you can change scales. So you can say free underscore x, for example. So if you say free underscore x for scales, although it's random normal data, so it's not the scales aren't that different. But you see, this one goes to -3. These don't. So the scales on the x-axis are now different per facet. And similarly, we can say free y, and then it'll do the same. It'll keep the x-axis fixed per all of them. And note, you'll note this is a little different. I'll flip back to the last one really quickly. But you see on these axes right here, they don't have any axis defined. That's because they're exactly the same. But when we did it before, and you'll see the y-axes are all different, but you'll see that they're defined on each one. But you'll see on the slide before that, when they all are exactly the same, it doesn't redefine the axes, right? It doesn't take up space for the exact same axis, so you know that they're fixed or they're exactly the same. And then you can say free in general and have both of them change. That's okay. The total free. That's kind of like if you want to do par mf row, right? Without setting x lim and y lim and base in some respects. But for the most part, I don't do that because usually when I'm doing multifaceted plots, I would like to compare things across them, and I like having the axes comparable, right? But there are some instances where you may want that not to be the case. So for example, let's do histograms, and I'm not going to use the new Geom. There's a Geom Joy package that just came out, which is kind of interesting. But let's do Geom Hist. I'm going to call this just gbase. And that's the other thing I really like, I'm going to comment these out, is that you can just start adding, like you can start with a base plot, let's say like this is this, this is this, and just start adding to it. So geom histogram. So you can't do X and Y and all that kind of stuff. So I'm just going to redefine the plot. Call it P. Let's say we just want to do a histogram of the X data. All right, so this is what it gives us. Not my favorite. I don't think that's necessarily the best thing, right?
Do you want to stack?
Yeah, I don't really like that. I like geom density.
Oh, yeah, that's much higher.
And where you say alpha is 0.5 or something like that. I like this, so you can see that. But a lot of times, I don't necessarily even like that. I like to do geom. So the other thing is, I like to map it to color. This is a little different. I'm going to change it. I'm going to keep the alpha to be 1. Here, I'm going to, so we can see multiple examples. All right, so I'm going to map it to the color. So in geom density, color maps to the line, right? And so when it does this, it makes it like a polygon. So I really don't like these lines at the bottom. That really annoys me. So what I tend to do is you can get the same result. You say geom line, but then you say the statistic that you're doing is the density. And this gives you pretty much the exact same plot, just without those godforsaken lines at the bottom that make it into a polygon. So I do these a lot, right? So comparability across, kind of histograms. So yeah, those are some of the examples I tend to do a lot, because I think a lot of times, almost always in the data we're working with, we want to do something. We want to do facets. We want to separate the data by some other variable, either by color or by facet. Lastly, what I wanted to say was Facet Wrap allows you to specify, for example, the number of columns. So this is, I think, a good example when you actually start to free up axes. So sometimes you want things to be comparable across the x-axis, but not the y. So you'd free up the y-axis, for example, like this. You can change n row to be 1, and then everything would be comparable across the rows, right? The y-axis would be the same, but maybe you change the x-axis or something like that. A lot of times, for example, I would do something like this where I might combine this with like histograms, right? So let's do this. Geom line, I'm going to say stat equals density, right? Facet wrap by group, right? N col equals 1. And I'm going to make, so common plots. Sorry, that's just an error because I've zoomed in. So this is one I commonly make. So there is something that's come out recently called Geom Joy. That really it's for like comparing densities, right, across facets essentially. But this is one I do. That's like kind of a new package, a kind of a boutique package of sorts that is for this specific reason. But this is something I do a lot, right? And then also, what I would do, let's say y is some outcome, right? So df, let's say outcome is df y greater than 0. Now, note, when I try this, it's going to fail. and I want to explain why that is. So df, we added the new variable, right? And I go to run this. It says object outcome not found. That's because when you do this step here, the ggplot step, it doesn't bind the data per se, but it's like whatever that data set had at the time is what the data is going to be. So like when you try to do something down here, it doesn't work because that was never in the data set to begin with. You can, what my suggestion would be many times is to go up and redefine, like just run that code. So like, move the code around. But sometimes let's say you have a data, like you've made a plot that's exactly the plot you want. You just want to plot a different data set in there. You can say, I'll call this, right? pnew, let's say. I can say pnew percent plus percent df. So df now has the variable in there. So now we have, right? So a lot of times if I'm doing, let's say, so for imaging analysis, I'm doing image segmentation. Like y equals 1 is positive, y equals 0. Like it's the object I want to see in the image, right? So a lot of times, let's say A, B, C, D, and E are different patient IDs, and their brain scans, for example, what I do, it's like, oh, I want to be able to distinguish them. And so what I'll do here is like do a plot like this and say like, hey, like let's say this is my, how discrepant are the y equals 1s from y equals 0 with respect to this variable? It's one of my predictors.
The percent plus
Yes.
percent will add
Is essentially redefining the data like in the ggplot command. So although we redefined it here, right, to say like, hey, pnew plus percent plus percent, and say re-add this data set in. This is a really helpful thing. If you've constructed an entire plot for a data set, and you have a new data set or a different data set that has the same structure and the same variables, and you want to take everything from that and just put the new data in there, percent plus percent will do that.
cool.
Oh, so you're just piping that new data set?
It's not
Not
essentially,
piping,
yes,
but
yes,
you're just,
exactly.
This is saying
Replace,
any reference to the previous data set.
exactly.
Okay.
So I'm going to keep that in there, but again, if it's the same data set and you're like, oh, I really want this, so what I'm saying is after you've defined the ggplot2 object using this, if you create new variables in the data, it might error if you try to reference them because it wasn't there to begin with. So you have to define new variables, then create the data set. Then create the plot. But if you happen to do it on the fly or doing it interactively, you can do this plus percent.
For just the same data frame again
After you've redefined the new thing. Yes. Okay. But that is not necessarily the use case, I would say. The use case is when you have two different data sets, you create an entire plot on one, and you're like, all right, let's just swap out the data, and that's how you can do it.
So no more cutting and pasting.
No more cutting and pasting.
Right.
And it's also like kind of a way that says like if your data set has this x variable, this y variable, this z variable, and then I have a plot for you. You just have to use this command.
It's interesting.
Right? So I'll say, yeah, so I was saying that multifaceted scatter plots with smoothers is something I use a lot. And stuff with different densities is really what I do a lot. So the one thing, Ggplot is still a good function, and I think that's really good because I think Rafa said this, and he said, the purpose of plotting, or at least 90% of the plotting he does, is for exploring the data, and he wants things to be done quick. So Ggplot is still good for that. I also, it's just quick plot. It's just it's kind of a short. It returns a ggplot2 object, so you can still add to it like you would later, but it allows you to find things a little bit easier, like kind of the same way plot is. So it's like you can define x, y, color, whatever, xlim, ylim, main, right? So it has almost the exact same options. So if you're like, I know plot, I don't want to learn ggplot, this is a good starter way.
Good start. And then you get the ggplot object, and you can play with it.
Exactly.
I see. Okay. That's what I need to do.
So
this is all part of the tidyverse?
Ggplot2 is part of the tidyverse. Yes.
And this is tidyverse refers to Hadley Wickham stuff?
Not just his stuff. There are other things in there. It was at one point called the Hadleyverse. He didn't really like that. He didn't like his name ascribed to it necessarily. He liked that but it was just it's not. He didn't like it attributed only to him.
Sure.
So it has per R, tidyr, ggplot 2, dplyr, readr, readexcel,
So is there a
broom.
Ggplot is the thing of the past then? Ggplot with no number.
So ggplot was like his first.
I used that back in the day.
It was his first, I think,
And
iteration
so
of it.
replaced that with Ggplot too?
Yes.
Super.
But
It's better than
yeah.
the first, though, right? That's a very rare thing for sequels.
Yeah.
Oh, it's like iterated.
Oh,
So
Tibbles.
it didn't work for Home Alone, but it did for Ggplot.
Yeah.
Tibbles.
TI. Yeah. So Tibbles are just they're different.
Is that cat food?
Tibbles are data frame. So I have DF. It's a data frame. Every time you print out a data frame, it pretty much prints everything you can up until the max print.
Oh, yes, I've seen this where it gives you
Tibble.
This gives you just the. This is when I first started my tutorial with dplyr. This is one of the first things.
So it's a Tibble. First off, the differences. It tells you what it is. This is a double. This is a character. This is a logical. Right?
Class.
So it only shows a certain amount of columns. Only shows a certain amount of rows by default. Also, it can have. Well, one, it never has row names, ever. So if you like to reference by row names, you have to make that a column. The other thing about it is you can have additional attributes to it. So when you do group by, I believe that always gives you a Tibble back because data frames don't have the ability to be grouped. Right? I believe that's the case. Group by, let's say, group. Load of dplyr. Let me just see what the class is this. Yep. So it's a Tibble, right? And it gives you groups. Right? Whereas if you do mutate or some other things.
So I'm sorry, so that just condensed, so I'm not familiar enough with what's in that table. So when you say group by, it just collapsed it over?
It doesn't do literal. Okay, so one thing I want to know, group by, I'm pretty sure always returns a Tibble. Other dplyr functions do not change the class of the object unless necessary.
So mutate is just select?
Mutate allows you to create. Mutate is the ability to create new columns.
New columns. Okay.
Create
so
new.
This is creating a logical column of whether y
Correct.
greater than 1.5.
Create new columns or replace existing columns. So if I say y equals this, it's going to replace y in there.
Got it. I see. So John,
Mhm.
and I'm sorry. If
Yeah.
anyone else has questions, do you?
No.
You just have answers.
Yeah.
Good. So I'm a dplyr novice.
Okay.
I do know some of this stuff because I started Code School's little video on it, and just listened to that in the background, some Tibbles and all that. But so when I'm doing my class, and in the first term I did things by base.
Send me something.
Okay, can I do it now?
Yep.
I'm just gonna find one.
So
I
we'll
think
talk
that-
about the most commonly used verbs of dplyr.
Let me just pull up something that will have the sorting and key apply stuff that I did. So look at doing that in. Sorry, I just have to remember what good. I made a lot of R code for this course. Not all of it efficient, maybe none of it, but.
So arrange, mutate, select, filter, group by. Am I missing any, Sean? Arrange, mutate, select, filter, group by, summarize, and then the helpers, modifiers.
Yeah, those are the core.
Okay.
Sorry, I just have to find. I have all this stuff. I just have to figure out which one's the best thing to send.
Yep. And I'll give you my very specific use case. my specific use case as why to use dplyr. Anything that does data manipulation. Anything. Oh, rename. That's another one.
Sorry, this is embarrassing, but I just can't remember which, I have multiple lecture sections for multiple lectures
Yep.
of our code. I just can't remember which. Is it lecture 2, section 3 that, has the.
Literally anything. Where you're doing anything.
But I specifically want to see how to do
Okay.
group means and group functions.
Got it. All right.
Sorry.
No problem. Here. How about this? How about we just start playing with some random data?
Yeah, how about I give you some idea? Is that cool? Can I
Yep.
just tell you what I want? 'Cause
Okay. Here are the verbs.
My memory training.
Here are the verbs that matter. Arrange. Okay. Here. Okay. Here. Let me make some random data. I'm just going to clear out the workspace. And I made the exact same data that we had before. Random normals and a grouping variable.
Okay.
Okay?
So 2 columns.
3 columns. Grouping variable is the third.
Oh, 2 random numbers. Sorry. Okay.
Yep. 2 random normals.
Yeah, no, I see.
Okay. So, I want to sort a data frame on X.
Mm-hmm.
This is the code to do it.
That's the base code, right?
Yep.
Mm-hmm. This is how I do that.
Why is that code crazy to a new user? One, it's got bracket notation.
Right.
It's got row, comma, column.
Right.
Second, you don't actually specify anything about the columns. It assumes all columns, which is not characteristic of a lot of other things in R.
Okay.
Second, you have a function in here. You have $ referencing. So you have 2 different ways of subsetting a data frame. You have the $, which already is a little bit confusing to a new user at times. You have a function in there. You have a function inside the bracket notation. And this works for characters and for numerics. But if you say, a lot of times you would say, okay, that decreasing equals true if you want to reverse it. Or some people say, hey, I want to reverse it. You just say negative.
Negative,
Right? That negative works for numerics, but it does not work for characters.
Got it. Okay. So
Right?
it's not consistent across classes.
It's not consistent across classes. Also, it gets much more complicated when you want to do things sorted ascending, descending, ascending, descending.
Oh,
right?
so I see. So you have multiple sorts.
Yes.
Like primary, secondary. Et cetera.
Exactly.
Okay.
So, like, let's say you wanted to sort on patient name, and then you wanted to sort descending on the date.
Got it.
Right? That's also, like, I've never even tried negative on a date. I don't know.
No, no, if that works with the brief.
So this
It's the same thing.
Yep.
And how do I do it? And beautiful. So you just.
All right. Let's say I want to do that. I want to do that. We'll go through each one of these.
So that's ascending on X, descending on Y.
Exactly.
Secondary sort descending on Y.
Yep.
Okay. That's beautiful. It's interesting because I've taught my students this order thing, but this is so much more eloquent.
Also,
Logical.
just to me, explaining what the order function does is difficult. So the order function, what it actually does is it gives you the indices when subset orders the data set. Right?
Right.
It doesn't give you the rank.
Right.
It doesn't give you the sorted thing back. It actually gives you an index to sort upon.
Right. So it's
Or
like,
yeah.
right. It's like a pointer to the.
Yeah, it's yeah. I mean, also, this notation is one thing. And you're like, oh well, I could get rid of the $ notation. This is my favorite. That is my favorite. That is my favorite way to specify a sort. Because not only do you have row, comma, bracket notation twice, you have to use quotes around the ends. Right? My favorite.
Like,
Hands down.
if you could just put in some subscripts,
Yep.
it would be perfect.
Most convoluted, but also like sometimes if you're like, I can just throw this in there too. And that means the exact same thing. Right? So you have 2 functions within each other, parenthesis map. It's just, and I'm saying I'm making it harder than it is, but like don't tell me for a minute you haven't seen code like this.
Right, no, exactly.
Right?
And I've used code like that because that was the first thing I saw.
Yeah.
And then I was like, wait, do we need to see? You know what I mean? But
And again, you've used R for years. I've used R for years. I know exactly what that does.
Right.
New
Right.
users don't.
Right, exactly. Why would they? And why
Yeah.
should they? Right.
Exactly.
So let me ask you this, John. So the things I need to do and teach students, and I'm going to be doing this in the second term as well. So I want to, let's see. I want to do let's do means by the index you put in. So just average,
Group means.
Okay, so then you create a new
So you do a data frame.
data frame, right?
Okay. So here's the thing.
So you are creating. So this DF is your data frame.
That's the random data I just created.
Right, exactly. But you call DF. So if you would call John, you put
Yep,
John there, right?
Exactly. I'm piping that in a group by.
Okay.
Nothing has been done to the data except an attribute of that data set has been changed.
And that column is called group, so that's why you say group by group, right?
Yes,
It's
I'll call it Z.
it doesn't matter. I'm just trying to.
Yep. Yeah. But I think that's probably better if I call it like Z.
So now you're creating the mean of the first column, which is called X.
Correct.
So you mean X, and so you give it this new column. So then this spits out a tibble. Now can I? Okay, this is beautiful. Now is a tibble like a data frame? If I wanted to pull out certain values.
Yep.
Okay,
Subsetting,
nice.
all that stuff works the same.
Thing. Okay.
Except, I'm not 100% sure. I'm not 100% sure about. Okay, here's a big difference. Subsetting single columns with tibbles returns a tibble.
Okay. Not a vector.
Correct. $sign still works fine.
Okay.
But this is at least consistent behavior where drop is always equal to false.
Okay.
Or drop is always equal to false.
This is fine because I could work with this. I just wanted to know if there was any. So then, I'm sorry. This is great. I mean, this is very straightforward. So now, John.
So hold on. Let me step back. So summarize collapses the data across this thing, across the group. You can have multiple groups in here. You just put comma, Z, Y. Yeah. Sometimes you don't want to do that. You can say mutate.
Oh, wait.
This is very, very different when it
So
does.
This creates.
Hold on. So
Sorry.
yeah. Let me just show you what it
That adds
spits
a
out.
column, right?
Adds a column. Now for every, let's see, D, for example. Let's look at D.
Right.
They all have exactly the
Right, so
same.
it's just replicating the.
Exactly.
Got it. So that's if you wanted this data in long format and you wanted to keep it.
So if you wanted to make a variable that was repeated the same thing across every row that had that group.
That grouping, right? So if you wanted to sum it, if you wanted to, yeah.
Yep.
So total number.
And then,
each,
you can start doing.
whatever. And you can get other. Yeah.
Yep.
That's beautiful. Okay. Now suppose this
Yep.
is really cool.
So
this is very straightforward. Actually.
this eliminates tapply completely to me.
Right. So now, simple question. Instead of using subset, I want to grab all of those values, group B or whatever.
Filter.
So okay, so that means
Filter.
so where did it go? I'm sorry.
Right here.
Oh, so how? Let me just answer this stupid question. How did it know to pull from DF for that one?
It didn't pull from DF. It pulled from means.
Oh, good because
I piped that in there.
You would out.
Okay.
I'm sorry.
Sorry. This is the so
I
again.
see. I'm sorry.
So
So can we go back to that? Then
This is
once
the-
you
this is the
create
same thing.
means,
I figured it out.
Means equals. Okay,
Yeah.
so it's not the arrow. It's equals, and then
So
this function
the pipe
applies
the
to
pipe
that.
just the pipe. The only thing the pipe really does is essentially translates that code
and applies it to the data frame.
into it translates that code into this.
Okay.
So instead of middle out interpretation, middle out evaluation, right, where you have to group by and then it's inside the summarize inside, right? If you want to do like 5 or 6 operations, this gets really. You either have to do one of two things. You have to do reassignment many times, or you have to do this very ugly nested thing.
Ugly nested thing, which you can easily mess up.
Yes. So that's what this does. says
Yeah.
df, pipe it into group by,
Mhm.
does an operation, that result, pipe it into summarize.
So then, if I had another grouping A or whatever, or some, so this was.
If you said
C
A,
was patients, A was dates, or whatever.
Yep.
And then I could do.
Yep.
And that's it. Beautiful.
that's it.
Just trying to think, what else do I do? That would be-
Okay, so select.
So that's where you sub.
Select-
So that's where you make.
So select is when you grab columns.
so you
filters
make-
when you
make
grab
a
rows.
data frame with, whatever.
Yeah. Filters when you subset rows. I'll talk about the modifiers in a minute. Mutates when you create new columns or replace new columns. But okay, so I'll talk about two things. One about mutate, one about renames columns, and then the other thing about filter. So filter, you can have multiple things. Like I want to say filter. I could say z percent in percent b or c, right? That's fine.
So that's.
You just have to give it a logical vector. One, it automatically drops NAs.
So it automatically saves.
Drops NAs.
Nice. So you don't have to do.
So it is essentially the equivalent of
remove
which,
NA, yeah.
right? So percent and percent doesn't matter. But when you do double equals, when you get NAs back, all filter does is say, where is it true? The same way which does. It says which on this condition returns the true indices subsets, and then it subsets on that. Filter, if you do multiple things, it is an AND operation by default. So you can put 10 things, it's this and this and this and this. If you want ORs, you have to explicitly state that. Right? This or this.
Okay, I see. So
That's all.
Mhm.
The condition, if it's based on, they may be making new operators like filter underscore OR. I'm not sure if that's actually going to come out yet, but by default, it says, this gives us B or C, gives it Z is in that or the mean of X is greater than, let's see, what is means? Greater than 0, let's say. So the code will be over here. So it keeps A, B, C, and E, right? It keeps this in B or C, or if the mean is greater than 0. But if I do this is different. It only returns B because is it in B and C and, right? So if you use commas, it's the equivalent of saying and.
And right. Okay,
Right.
Okay, got it. Okay, got it. 'Cause C had a mean of less than 0.
Yep.
Got it. Okay.
The other thing is mutate. Mutate, you can do things sequentially. So when we were teaching people who, for example, worked in Stata, we do this. Let's say Q equals NA. So gen, blah, Q equals period. Right? Q equals, if else, let's say y is less than -5. Bad. Otherwise, keep it as Q. So replace if y is less than -5 equal bad. Or replace Q equals bad if y is less than -5. Replace Q equals okay if y is less than 5. Right? Let's do 3 and 3 because this is random. This is random normal data, so we know where they're going to fall. Right? So replace this if it's less than 2.5, it's like -2.5, it's bad. If it's less than 2.5, it's good. Right?
Right.
And so it's saying again, replace Q equals good if y is less than 2.5 and it's not not missing.
Right. Okay.
Right? Otherwise, just keep it as it is.
And in which case, yeah.
Yep.
So if it's missing, stays missing. Right.
Greater than or equal 2.5, large. Right? You can create and then reassign it.
Okay, got it. So it's not.
I screwed up there. Something.
Something went wrong. But still, I've seen.
So let's see. if else y is less than negative 2.5 bad, otherwise replace it to be q. If else y is less than 2.5 and it's missing. Sorry, it's supposed to be missing. And it's still missing.
Oh, y is. I'm sorry. Yes.
It wasn't redefined already.
I
Yeah.
was thinking y. Okay, got it. Yeah. Sorry, I was. Yes.
So now, like, so let's just. I just want to see a couple things. So let's make it a tibble. So they're all within that. So we can now table df q.
What you could do. Okay.
Right. Yeah.
Perfect. Oh, this is really good.
Right. So mutate. The nice thing about it, you can do things sequentially. Right. So when you ran this command at the outset, right up here, the first line q was never defined.
Right.
You defined it, and then every subsequent step it already knows the previous steps have already been executed.
Right.
Okay.
This is nice. So you don't have to define an empty vector beforehand.
You don't have to if you don't want. I mean,
No, I mean, usually what I do is create a vector of zeros and then, or
Yeah.
NAs and then go through and replace,
Yeah, so really
And
what...
this does this all in one...
Exactly. Really what you can do is just say like this.
That should be fine too.
That should be fine too. But for people who come from stated, this is the process they think in.
Right. You first have to initialize the
Yep.
NA, right?
And then there's also if underscore else. Which
I'm
is...
sorry, I was getting confused with looping where you have to set up the...
It's if underscore else is... the only difference between that and if else is it's really strict on the types. So if you try to replace like the first thing you replaced it with was like a character, and you start to try to replace it with numeric, it's like, hey, like you can't do that. And you could...
What happens in if else? It just defaults to character?
It'll do coercion.
Coercion, right?
Yeah. Rename. Oh, and then selector. So okay. So the other thing that's really, really helpful. Hey. Where did it go? No. I'm not talking about that.
Wait, can I have your driver's license, Audie?
Oh. So okay, select helpers. Sorry, they're not called modifiers anymore. If you look up select helpers, get out of here. These are helpers for the select command. Starts with, ends with, contains, matches, num range, one of, everything. So this allows you to do standard string matching on the column names of a data set. Like let's say you have visit 1, visit 2, visit 3, visit 4, visit 5.
Oh, I see.
I can say starts with visit. And then, so for example, let's say I want to select data frame X and Y. That'll grab out X and Y. Let's say I want to say select minus Z. So minus, just like negative indexing in R, drops it. Gives me everything but that. Let's say I want to reorder a data frame. Select Y and then everything. That'll put Y. I'm just going to do that again. I'm just going to make it a tibble.
Does everything just mean everything else?
Everything else. So it puts Y at the first column.
And it, okay.
Right?
Oh, so you mean just reorder the column?
Literally reorder.
Got it.
Again, stated people really think that way.
Could you do Y, Z, everything?
Yep.
So you can, okay. So this is just stated silly thing where you have to, it doesn't stay this clunky with this, with the order. And,
Yeah.
Okay.
Right? Rename.
Oh, so you put the new name first. Got it.
Yep.
Beautiful.
So we go back all the way to the top.
This is awesome.
New X.
I'm sold. So I haven't started my R lectures for the second term. I'll be working, so that we're just going to do this.
Yep.
I'll just be like, guys, there's a new way in town. You might appreciate it.
Yeah.
Let's lay it out.
I mean, a range is really... So summarize. Okay, there's a couple other helper functions if you want. Tally. Tally is essentially a Okay. There's tally. There's add tally. Which, for example, let's do. I'm gonna rerun everything. So let's do df. Let's group it by z. Tally. Just does a simple frequency table.
Oh, it just does. Okay.
But let's say, I don't know if I can actually do this. Yep.
Yep. Beautiful. Oh, so this is great. So this is just counts.
Yep. Counts. Granted, that doesn't take into account missing data.
They are included, right?
I mean, it counts the number of rows.
Right.
That's all it does.
Right? It's totally number of rows.
Summarize, you can say summarize n equals n, not n0. Same thing. Tally is essentially tally. Okay, here is the big.
I see. Okay.
The big difference is tally. Tally's a shortcut essentially. The other things you want to do, for example, slice. So there's first, last, nth. So like an underscore n equals 1 in Stata with a by on it. By patient name gen first date equals date if underscore n equals 1 or date 1. You can do that. So the first, last, and nth work on vectors and give you the first, last, or nth. Slice is if you want to grab rows by. Yep. So you'd say slice data first row, so it works on a data frame. Okay? But it can work on a group data frame.
Group data frame, right?
So let's say I want the first visit information for every single person. Group by patient name, date, arrange. Well, you have to sort it first, right? So if you sort by patient, date, group by patient, slice 1, gives you the first record for every single patient.
So is that, John, would I have to do that all within slice then?
So you say data frame, for example,
Sort,
arrange,
right?
patient, date, group by just date, or sorry, patient, slice 1.
Oh, so you do it within the and so that knows with respect to the grouping factor.
So let's.
Is that right?
Yeah. So let's do this. So let's arrange it by z, and then x. Group it by z. Slice the first one. Gives us the record with the lowest x per z.
Lowest z. Right. Okay. This is great. I have to run.
Yeah.
But this is awesome. Thank you so much.
So this will be uploaded on the website with the video.
Which website?
My website. If you go to johnmichelli.com and then click Faculty Office Hour.
That's awesome.
It'll be up here. All right, with the Ggplot code and the dplyr verbs.
I'm thrilled.
Okay.